Okay, practice test 3. In this assignments, there are 30 questions. I'm going to do, this assignments. If questions are repeated, then I'm going to skip those questions. In actual test, there will be 20 questions only, but in practice test, there are 30 questions. Okay, the first question is find the x-intercepts and then y-intercepts. So whenever we have to find the x-intercept and y-intercept, for finding the x-intercept, we just have to solve f of x equals 0. That gives us the x-intercept. So meaning we are going to solve this quadratic equation, which is, if you just use the factors, there is a negative 15. So 5 times 3 is 15, but here is a negative 2. So that's why negative 5 times positive 3. That gives you negative 15. Negative 5 plus 3 gives you negative 2. That's why these are the two factors. By solving these factors, x equal 5 and x equal negative 3, these are the two x-intercepts. Okay, for the y-intercept, that's for the x-intercept. For the y-intercept, we need to find out the value of the function when x is 0, which means in this function we're going to put x equal to 0. So that gives the y value negative 15. So this is y-intercept and these are the x-intercepts. So the x-intercept are 5 and negative 3. 5 comma negative 3, and then y-intercept is negative 15. Yeah, that's right. Let's go to the next problem. Again, we are finding the very same thing. The x-intercept means when function is 0 and solve for x, and then y-intercept means when x is 0 in the function. So I'm going to skip this one for you. Here in this problem, we need to find out the domain and range of this graph. Domain means from what point to what point the graph is moving on the x-axis. So if you just zoom in this graph here, as you can see that the starting point on this graph for the x value is negative 7, right, including that point. So negative 7, and it's going up to, this arrow means keep going, so there is no stop on the right side. So the domain is from negative 7 including negative 7 to positive infinity. And then range means, as you can see that this graph is going to approach this line y equal to 2, but this graph is not going to intersect with the y equal to 2. So y equal to 2, that is the y value, is the minimum value on this graph, but not including that point y equal to 2. And then maximum value on the y-axis is going up to 7. So the range means it's a y value. So you are going to look at the value on the y-axis. So the domain of the function is from negative 7 including negative 7 to positive infinity. Negative 7 to positive infinity. And then range is the y value starting from positive 2, which is bounded below by this line y equal to 2, but not including 2. That's why it's a parenthesis 2. And the y value, the maximum y value, as you can see, is the 7 including 7. So bracket 7. Okay. Next problem, we need to find out the interval where function is increasing, decreasing, and constant. If you look at this graph, as you can see that if you go from left to the right, the graph is going up, 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 up to this point where the x value is negative 5. So from negative infinity to negative 5, the graph is increasing. And then from negative 5, it's going down up to positive 5. And then from positive 5 again up to positive 12, the function is again increasing. So here you can see that the function is increasing from negative infinity to negative 5 and from positive 5 to positive 12, and then function is decreasing from negative 5 to positive 5, and there is nowhere where function is constant. So the function is increasing from negative infinity to negative 5. Type your answer in interval notation. Use comma to separate answer as needed. So we have two different intervals where function is increasing. So from 5 to 12. Okay. and then function is decreasing from -5 to +5, and there is no place where the function is constant, so there is no solution for the third one. So here again we need to find out the relative maximum minimum. So first question is, for what values of x does the function obtain a relative minimum? So if you look at this graph here, the minimum value of this function is at 0, which is the value is -1. Okay, and then maximum value, as you can see that this graph is going to approach y equal to 1. The y equal to 1, that is the maximum upper bound, but the graph is not going to intersect that point. So the value of the maximum value of the function is not there. Okay, so let's answer the question here. The function obtains a relative minimum at x equals 0, and then the relative minimum is -1. As you can see, that's -1 here. Select the correct choice below. The function obtains a relative maximum. There is no maximum, so there is no solution for relative maximum. So as you can see that this function, as you see, the graph is bounded by y equal to 1, but actually there is no value which is the maximum value, which is slightly less than 1, but we don't know what is exactly that value. So that's why we say no relative maximum. Okay, next problem, we have to plot this graph of identity function f of x equal x. So that should be a straight line from -3, including -3, to +2. So graph A, B, D, H, G, and E, they are not right graph, because this is the identity function, means a linear function that should be straight line. So your choice would be either C or F. But when the value of x is -3, the function should be -3. So let's look at this C. If I look at C, at -3, the value of the function has a circle, so there is no value. So this point is not included. So that means this is not the right graph. If you look at F, at -3, the function is -3. At 0, the value is 0. At +2, the value is not included. That's why the right answer would be F. Let's go to the next problem. Very similar kind of idea. This is the reciprocal function, and we need to choose a reciprocal, means either it's a C or F. And as you can see that we are just looking for the value from -4 to +4, from -4 to +4, and not including -4. So if you look at here, this graph F, the -4 is not including and +4 is including. That's why this is the right one. Okay, this is the graph of basic function with a restricted domain is given to the right for the graph. We need to find out the domain. The domain means the x value. The x value is going from -3 to the +3, but not including -3. That's why we need to write a -3 comma +3, including +3. The graph represent the function f of x. So this is a part of cubic function, so it should be x cubed. And then as you can see that the domain is going from -3 to +3. So here we have to write down the piecewise function. As you can see, if you look at here, this function is made of three different lines. This line to the left of 0, this line between 0 to 1, and this line from 1 to -5. So there are three lines we need to write it down. So there should be three different boxes, as you can see that. Where is that? Where is that? Okay. So for the first one, if you look at here, on the left side, this is the line passing through 0, 0 and -5 comma +5. So that is, we need to find out that line. So let's do that. Let's try to write it down. Find out the equation of line which is passing through 0, 0 and -5 and 5 and 0 0. So that's the first line. So this is problem 9. We would like to write down the equation of this line passing through -5 and +5, and then another point is 0 0. So we need to find out the equation of this line passing through 0 0 and -5 5 by using for that we need to find out the slope of this line. Slope is y2 minus y1, 5 minus 0 over x2 minus x1, which is basically 5 over -5, which is basically -1. And then equation of the line, we have this standard formula for the equation of the line, which is y minus y1 equal m times x minus x1. We're going to use very same formula for that equation of line, so in this case, in this particular case, we can keep x1 and y1 as 0 0, and then slope is -1. So if we do that, uh, y1 is 0, slope is -1, x1 is 0, so this is y equal negative x. So y equal negative x, that means the function is negative x if you go from negative infinity and when x is less or equal to 0. Okay, that's the function. So function is less than x if x is less or equal to 0. So that's the graph when x is less or equal to 0. So if you go from 0 0 to 1 1, there is this graph. If you look at here, the graph is this one. It's passing through 0 0 and 1 1. So now what kind of graph is this? This is again, if you try to find out the slope would be y2 minus y1 over x2 minus x1, which is basically 1. So equation of line would be again y minus y1 equal m times x minus x1. So which is y minus 0 equal m is positive 1, x minus 0. So the equation would be y equal x. So the function is x when x is in between 0 to less than 1. So remember, on the left side this is f of x equal negative x, and on the right side it is f of x equal positive x. So combinedly we can write down that as f of x equal absolute value of x when x is less than -1. Less than -1 means this absolute value of x means it's everything on the left side of x. We can write it down because as you see here, the options we have given, there are only two parts. So we cannot write down three different functions. We just need two functions. So for the first line, the left hand side, and this line, this tiny line, this is actually absolute value of x. And to the right side of 1, as you can see here, the graph, we have this graph, which is at 1 the value is 0, and at 6 the value is -5. We need to find out the equation again, and for finding the equation again we need to find out the slope, which is y2 minus y1, 0 minus -5 over x2 minus x1, which is basically 5 over -5, which is -1. So the equation of the line one more time, which is y minus y1 equal m times x minus x1, which is y minus y1. If it's y1 and this is x1, it would be y uh, plus 5 equal -1 times x minus x1 is 6. So if you just simplify this one, it will be y plus 5 equal -x positive 6. Just subtract 5 from both sides. That will be y equal -x positive 1. So that is the value of the function on the when x is, as you can see here, greater than a 1 and go up to 6. Okay, so when x is greater than 1 and go up to 6. So we can divide this function as we have what is that, which one is look like that. Okay, a, if f of x is absolute value of x, if x is less or equal to 0, not less or equal to 0. For the first one it's just less than 1, so this is not the right choice. Second one, so our function should be look like this. The function should be absolute value of x if x is less than 1, and another part is a negative x plus 1 if x is greater or equal to 1 and go up to, what is that, positive 6, positive 6. So we need something, this one. So this is where we have to focus. X is less than 1, there should be less than sign, and there should be equal sign. So the only choice we have is B. Look at here, x is less than 1, less than 1, and x is in between positive 1 to positive 6. And then value of the function is on the first part, it's absolute value of x, which is here, absolute value of x. And for the second one, this is negative x plus 1. So if I choose this one, that would be our right answer. Okay, let's go to the next problem. This is also piecewise function, depending on the value of the function. Here we're going to find out the value of the function at different points. So for example, what happens to this function when x is 1? X is 1 means we're going to choose the first part, because x, there is an equality sign here. As if you focus here, for anything less or equal 1, this is the first part of the function we're going to use. For anything greater than 1, we're going to use the second part. So for finding the value of the function at 1, we're going to plug x equal to 1 in the first part, which is 3 times 1 minus 4, which is basically negative 1. For x equal to negative 1, again we're going to use the very same thing, because that is also to the left of 1. So if you put x equal to negative 1 here, it will give you negative 7. And for x equal to 2, we're going to use the this x plus 1, which is 2 plus 1 is 3. And now based on this value, as you can see, that just plug this value on the left side. So check here, these are the lines. So as you go here, let's check the first one. For x equal to 1, the value of the function is negative 1, but this is not negative, this is positive, so this is not the right choice. Let's go to the second one. For x equal to 1, the value is negative 1, including negative 1. Yeah, that's right. When x equal to negative 1, which is here, the value is negative 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that's right. And when x equal to positive 2, 1, 2, the value is positive 3. 1, 2, that's not positive 3. 1, 2, 3. So this is not the right choice. So let's go to the next one. So the function should look like this. The graph should look like this, but with the correct value. So this is not the same one. So this should be, uh, where is that? Maybe when x is 2, that is 3. So let me go back again. When x is 2, 1, 2, 3. Yeah, this is the right one. When x is 2, 1, 2, 3, 3. This is the right one. So B is the only right solution. Okay, so now here where we have to use the transformation. So when we have to sketch the graph of this function like this, we need to find out what is the standard function, what is the basic function we're using to plot the graph. Use the graph of the known basic function. To find out the basic function, just remove, think about the function without this constant, any constant you have given. Meaning in this case, it's a think about the function without using that 5 and 4. So this is problem 11. So what happens to this function h of x if you don't use 4 and 5? There is a 4 and 5. If we don't use this 4 and 5, so I'm going to show you here. It's easy for me to just erase those option 4 and 5 and to see the basic function for us. So what is that? If I just remove this 5, which is constant, and then the number inside that radical sign, so that will give us the basic function. So this is the basic function we need to use to plot the graph of this one. Okay, so to go from square root of x to, so square root of x is the basic function. So to go from square root of x to let me just go back here. This is not, this would be, that's not the same name, so you have to use, we could use different name here just to make sure that we are not using the same function. So This is the basic function. We're going to use the basic graph of the basic function, which is the square root of x, to go to the square root of x plus 4. So what kind of transformation we are using here? So that's what we need to find out. So from square root of x, we can go first to square root of x plus 4, and then from there we can go to the square root of x plus 4 minus 5. This first transformation is the horizontal shift to the left 4 unit. Horizontal shift, horizontal shift 4 units left. And from here to here, it happens if you do the vertical shift 5 unit down. Vertical shift 5 units down. So to start from the basic function, to go from here to here, you need to do the horizontal shift, and to go from here to here, you need to do the vertical shift. So now let's answer this question after knowing the basic function. Choose the correct sketch. So we are using the graph of the square root of x, and we're taking that graph to the left 4 unit and 5 unit down. So this is the graph of square root of x, and we're taking that left 4 unit. So this 0 0 becomes negative 4 0, and that goes to down 5 units. So that would be negative 4 negative 5. So we need to find out which graph has negative 4 negative 5. It doesn't have negative 4 negative 5. It does not have negative 4 negative. This has positive, this has positive. So the only graph, if you look at here, the option you can see is negative 4 1 2 3 4, and negative 5 is this one. So this is the right option. What is this? The graph to the right was created by using one horizontal shift and one vertical shift of absolute value of x. So if you focus on this graph is the absolute value of x starts from 0 0, and it's going up 4 unit and left 1 unit. So we always do the horizontal shift first and then vertical shift. So this graph is left 1 unit, so that means you have to add 1. So that's the left shift, and then add because it's going 4 unit up, so you have to add 4. So that's a left 1 unit and 4 up 4 units. Okay, this is also transformation. We are answering the question about the transformation, and the basic graph is the graph of 6 times cube root of x is a vertical stretching, because we're multiplying by 6, which is greater than 1. That should be vertical stretching of the function, which is the basic function is cube root of x, cube root of x, cube root of x by factor of what is that, 6. And then it's just stretching, so it should be graph look like a graph of cube root, but stretching by 6 units. So this one is it's a vertical shift of cube root, so this is not the right one, because that point 0 0, as you can see here, it's moving down, but if you multiply, that should not move down. So there should be 0 0 point. The only two graph has 0 0. This is 1, which is at 0 there is a 0, and this is 1, at 0 there is a 0. But in this case, this is the vertical stretching, it's going up than this one, so that's why this should be the right answer. Okay, use the graph of known basic function and a combination of transformation to sketch the function. So look at here, what is the basic function here? Just think of the function without this constant number. So remove this 2, remove this 5, then leftover would be 1 over x. So the basic function is 1 over x, which is reciprocal function. So that is our starting point. So this is problem 14. For the problem 14, the basic function is 1 over x. From 1 over x, first of all, we do the horizontal shift to the right, which is if you subtract to the x, that means horizontal shift to the right. And then if you add to this previous term, which is the adding to the y coordinate, that means it's the horizontal shift. So from here to here, it's a horizontal shift sorry, this is vertical shift, this is the horizontal shift. From here to here, the first step is horizontal shift to the right 5 unit, and from here to here it's a vertical shift 2 unit up. So this one is horizontal shift 5 units right, and this is vertical shift 2 units up. Okay, so the graph of reciprocal function, we already know the graph of reciprocal function, that's the basic graph, should look like this. We are taking this graph, taking everything 5 unit to the right and then 2 unit to the up. So that's what we have to choose. 5 unit to the right, it should go right, and 2 unit up. So 5 unit right, so that means here you can see that it's coming to the left because this upper part is going to the left side of the 0 0. So this is not the right one. So this one, as you can see that this is also to the left side, so this is not the right one. This one, it's going to the right but coming down, so this is not the right one. For our case, we need going to the right and going up. So this is the only case where you see it's going to the right and going 2 unit up, 1 2 unit up. Okay, so this is the only one option we have available. And you can also, check this thing by checking some points. If you want, you can just plug x equal to 5, let's say you know 10, or 2 or 3 or whatever you want, and find out the accurate point. Here we need to find out the value of the function f over z. That means there are two functions. F over z means you have to find out the value of the function f at 0, value of the function g at 0, and then just put that value on the top and bottom. So it's a just algebra function, so which is as you can see, this is 15. F over z means divide the function f at 0 and then function z at 0. So divide this function at 0 by function g at 0. So on the top, the value is square root of 4 because 0 plus 4 is square root of 4. On the bottom, the value is 0 minus 6, so which is 2 over minus 6, which is negative 1/3. Okay, negative 1/3. Sorry, 1/3. Okay, let's go to the next problem. Next problem is here again, f times h. We want to multiply this to function at 14. So just do that. F, that's is very same thing. F times h at 3 is, no, not 3, it's 14. Find the value of the function f at 14, value of the function h at 14, and multiply them. So for finding the value, just plug x equal to 14 in the given function. So for the first one, it's a 14 plus 2. For the second one, it's a 1 over 3 times 14 plus 2, which is basically here it's a square root of 16, which is 4. And here it's a 3 times 14 is 42, plus 2 is 44. So if I just cancel this, it would be 1 over 11. So type an integer or simplified fraction, so that means 1 over 11. Here f composite g, in this case we would like to find out f composition j, and there is a way to find it. There is a this is problem 17. F composite gx means find the value of the function f at g of x. So look at the function f, which is 3x plus 6. Replace that x by g of x. That's what it means. So the g of x, again, g of x has a different value, so eventually you have to plug that value back here. So that will give us 8 times 3 is 24 over x plus 6 plus 6. Because we need to simplify our answer, so we can just add this by making the same denominator. So we can make this 6 as x plus 6 over x plus 6, and then we can just make the one denominator x plus 6. On the top there will be 24 plus 6 times x is 6x plus 6 times 6 is 36. So that will give us 6x plus 24 plus 36 is 60 over x plus 6. So if I factor, okay, I did a little bit more here because we need to simplify as much as possible. So we need to factor the common factor on the top, which is 6x plus 10 over x plus 6. So there is no common factor on the top and bottom, so we can just leave it like this. So the answer would be 6x plus 10 divided by x plus 6. We can write down this 6 on the top as well. That's the simplified form. Next question, this is also composition, so only the difference is we need to there is just two different functions, so I'm going to skip it. That's the same idea. Okay, so I'm going to skip this. Again, it's the same idea, but we need to find out the composition at 1. So instead of finding at x, we need to find out at 1. So meaning is this is problem 19. Z composite f at 1 means it's find the value of g at f of 1. So to do that, first of all, find out f of 1, which in this case it's x 1 minus 5, which is negative 4, and find the value of the g at negative 4. G at negative 4. For that, you have to use the second part, which is square root of negative 4 plus 13, which is square root of 9, which is 3. So the answer for this one is 3. Okay, what kind of function is this? Is this a one-to-one function? One-to-one function should pass the horizontal line test, but this is a parabola. This is quadratic function. So if you try to draw the graph of this function, you can see that the graph would look like this. And this graph does not pass the horizontal line test. So that means it's not one-to-one. No. What about this? Again, this is quadratic function, but this is restricted when x is greater or equal to 5. So if you try to use quadratic function, x minus 5 whole square, this is actually, this is x square, this is x square. And then if you want to plot the graph of x minus 5 whole square, so you are just using the same graph, but moving it to the 5 unit to the right. 1, 2, 3, 4, 5. So this is the graph of x square minus 5. But you are looking for this graph only when x is greater or equal 5. So only this part. So the graph of this one on when x is greater or equal to 5 look like this. Okay, so this is one-to-one function on this domain when x is greater or equal to 5, so that means it's a yes. Now we have given function f, and we need to find out we need to plot the graph of f inverse. So remember, whenever we try to sketch the graph of f inverse, we just have to switch x and y coordinate. So on this graph you have 3, 8. So on the inverse there should be 8, 3. On this graph you have 0, 7. On the inverse there should be 7, 0. On this graph you have negative 1 comma 6, and then on the inverse there should be 6 comma negative 1. And then those two graph f and f inverse should be look like mirror image if you place the mirror on this line. So find out the graph among these four graphs which has this point 8, 3, 7, 0 and 6 negative 1. 8, 3, 7, 0 and then 6 negative 1. So what is that? So let's find out. This is 1, 2, 3, 4, 5, 6 negative 1, 7, 0, 8, 1, 2, 3. So this is the right choice. So this is the right choice. The domain of f is, as you can see, that the domain is the starting point, which is from negative 1 and going up to, there is no end point, so going up to positive infinity. So including negative 1 to positive infinity. That's the domain of f. And the range of f is, what is the range? Where range is going? the range is from positive 6, range means y value, positive 6 up to, there is no stop here, so you are going up. That's what you know I'm assuming here. There is no stop here, so the range of f is what is that, positive 6 to positive infinity. And now the domain of f inverse would be just switch, if you just switch them, that will be the range will be the domain of f inverse, which is 6 to positive infinity. And then range of f inverse is the domain of f, which is from -1 to positive infinity. And that's we can verify from the graph here. Look at here, this is the right graph. The domain of f inverse is starting from positive 6 and it's going, keep going, and there is no stop sign here. That's what I'm assuming here. uh, so let's try this one, and then let's see. Okay, that's right. So the idea is the domain of the function would be the range of f inverse, and range of the function would be the domain of f inverse. We are just switching x and y coordinate for the f and f inverse. Again, to answer this question, you just have to play with that inverse thing. So I'm going to skip this. This is very similar to the previous problem. Okay, here we need to find out the inverse, and to find out the inverse function, we can use a step-by-step process. So first of all, we need to write down that function in terms of x and y. So write down that f of x as y equal half x minus 3. That's the first step. Okay, the second step, we need to exchange x and y. So this y becomes x because we're trying to find out the inverse. And then third step is solve for y here. If you try to solve for y, you were just keeping this y on the one side and everything else on the other side. So for that, I'm just going to add 3. So that will be x plus 3 equal half times y. I just need y here. I don't need half. So I'm going to multiply both sides by 2. So my y would be 2 times x plus 3. So whatever I get for this y, that would be the inverse of the function we have given. So this is actually f inverse. So what is f inverse? That is 2 times x plus 3. So f inverse is 2 times x plus 3. And then by looking here, the domain is all real number because it's a linear function. So it's from negative infinity to positive infinity. Positive infinity. The range of f is, again, it's a linear function. So it's again from negative infinity to positive infinity. All real number. There is no restriction because the domain of f would be the range of f inverse, and then the range of f would be the domain of f inverse. They will give you the same thing again. All real number, negative infinity to positive infinity. And here again, it's a negative infinity to positive infinity. Positive infinity. Okay. Wow, I missed something here. So let me go back and try to find out what did I miss, because my score is just 80%. So what did I miss here? So let's try to find out. Let's go to this problem. Y equal half x minus 3. I add 3, so it will give me x plus 3. And if I multiply both sides by 2, that will give me y equal 2x plus 3. So that is inverse f of x, f inverse of x. That's right. So what I'm missing here, did I miss something here? Um, Simplify your answer, use integer or fraction for any numbers in the expression. I don't know what I'm missing here because this is the right answer. Do I have to use multiplication? So let's say I'm going to use multiplication, and let's me check. Again, it's give me. So the domain of f, this is a linear function. It's a one-to-one. It's all real number. Type your answer in interval notation. That's what I did. The range of f, again, it's a one-to-one. So it's and there is no restriction for f. So it's everything. The domain of um, the domain and range of f inverse. Again, this is a linear function. So the domain is all real number. and then range is also all real number. I don't know what I'm missing. It should be the right answer. So let me just, no, that's the right answer. I don't know what I missed here. I add 3, so that gives me x plus 3, and then multiply by 2, so that will be a fraction for any. Okay, let me just distribute this 2. So what I'm going to get, 2x plus 6. Let's see what happens if I do this. Oh yeah, yeah. So it did not recognize that 2 outside. So make sure that, yeah, that's, I didn't know that, it does that. Simplify your answer, meaning you just have to distribute that 2. So I was not distributing that 2. So make sure that if you get that 2 outside, just distribute that. It's supposed to give you the 100%, but you know, so it's weird. Okay, let's go to the next one. Um, Write an equation for the inverse of the given function. We're going to do the same thing here. That's the changing x and y and then solving for y, and that would be the inverse. I'm going to skip it for you. Given the quadratic function in vertex form, find out the vertex. So if you have quadratic function in this form, that's called vertex form. Let me see, a times x minus h whole square plus k, then h comma k is our vertex. So in our case here, h is 1 and k is 5, so the vertex is 1 comma 5. Okay, does the graph opens up or opens down? Since the value of a is negative here, if the value of a is negative, then graph opens down. And what is the equation of axis of symmetry? The axis of symmetry always comes from x equal h. In this case, h is 1, so x equal 1 is the axis of symmetry. Okay, this is quadratic function, and then we need to find out right graph for this quadratic function. So first of all, the value of a is negative, so that means the graph should be either c or d. But to find out the right graph, you can find out the vertex, and then from there you can figure it out, or you can just find out the y-intercept and x-intercept. That might be helpful here instead of finding the vertex. Okay, so if I find the y-intercept, the y-intercept should be 9. So let's check here, what is the y-intercept? It's 9. Let's check here, what is the y-intercept? That is also 9. So y-intercept is not helpful for finding the x-intercept, meaning if you try to solve for that looks a little complicated than finding the vertex. So I'm going to find out the vertex, or maybe you can just find out the value of this function when x is, let's say 1. If x is 1, the value of the function would be negative 3 plus 7 plus 9, which is 9 plus 7 is 16 minus 3 is 13. So when x is 1, the value of the function should be 13, but gives you 0, so this is not the right one. Let's go here. When x is 1, the value of the function is 13. So this is the only one graph which satisfy my requirement here. Concave down, and when x equal to 1, that is 13. Okay, so what is the domain? After looking this graph, we can find out the domain. Domain is, as you can see here, domain is all real number. The domain is all real number from negative infinity to positive infinity. And what is the range? Range is, because it's concave downward, the range is everything from bottom up to this point, which is what is that, positive 13. So the range is from negative infinity to positive 13, including positive 13. Okay, wow, did I do something wrong here? What did I do something wrong? Oh yeah, I missed the negative sign here. It should be from negative infinity up to positive 13. Again, I missed something. What did I do? So let me go back here. The domain is all real number, and then range is, if you just focus on here, the range is, this is the maximum point, and what is the maximum point? That is 12, and then that is 13. So the range is from negative infinity. Here you don't have negative infinity, they are giving you negative 20 to positive uh, 13. It should be right. I'm not sure why it's not right? So let's find out the vertex to check, the to find to find out the exact maximum value. So vertex can be found for problem like this. If you have quadratic function, the vertex can be found. The x coordinate of the vertex is negative b over 2a. In this case, b is 7 and then a is negative 3. So that is negative 7 over negative 6, negative b over 2a, which is 7 over 6. So this is the x coordinate of the vertex. So the y coordinate, which is k, is the value of the function at 7 over 6. So that's the reason that's not exactly 13. So they want us to find out the vertex to answer this question. By looking the graph, I saw, I thought maybe it's 13, but that's not the right. Let's find out the value of the function at 7 over 6, which is negative 3 times 7 over 6 whole square plus 7 times 7 over 6 plus 9. If you use your calculator, you can use simplify your answer, type your answer in the interval notation. So that is negative 3 times 7 is 49. This is 36 plus 7 times 7 is 49 over 6 plus 9. Let's add this number. We don't want simplify your answer. So let's try to add this. Negative 3 times 49 is what is that? 150 minus 3 is 147 over 36. I can make this 36 by multiplying the top and bottom by 6 and then this by 36 over 36. So if I do that, 49 times 6 is what is that? I'm going to use my calculator here. 49 times 6 is, okay, 49 times 6 is 294 over 36 plus 9 times 36. 9 times 36 is 324 over 36. 9 times 36. So now if we add this number on the top, which is negative 147 plus 294 plus 324 over 36, and let's do the simplification. Plus 294 minus 147, that is 471. So that is 471 over 36. Okay, 471 over 36. 36. Can I divide that? Okay, 471. 3. Can I divide that by 3? Um, yeah, so I can simplify this. 471 by 36 by, there is a common factor 3, which is 3 times 1, 5, 7 over 36 means 3 times 12. So 3 cancel out. This is not divisible by 3 or 2, so this is the simplified form, 157 over 12. So this one would go up to 157 divided by 12. So let me use this one. Okay, now it's 100%. Did you notice here? I was trying to answer the question just by looking this graph, and I thought this is the maximum value, which is close to 13, so it should be 13, but that's not the case. The answer is 157 over 12, which is approximately equal to, if I divide 157 by 12, it is 13.083333, which is approximately equal to 13, but not exactly equal. So to answer this question, we need to find out the vertex. Only way we can answer this question is by finding the vertex. Okay, again, quadratic function and then maximum or minimum, we can find out the vertex, and if it's concave down, there will be maximum. And what is the maximum or minimum? We need to answer this question by finding the vertex. I'm not going to find the vertex one more time for the similar question, so I'm going to skip it. Here is the word problem. A baseball player swings and hits a popped fly straight up in the air to the catcher. The height of the baseball in meters t seconds after it is hit is given by quadratic function. So it's about quadratic function. How long does it take for the baseball to reach its maximum height? So remember, whenever you are trying to solve a problem related to quadratic function, you will be able to find out its maximum or minimum value by finding its vertex. So this is the quadratic function. You can find out the vertex, and that will give you the maximum height, and that will give you the time when you can find out the maximum height. So in our case here, what is this? The height function is the quadratic function. This is problem 29. Height function is negative 4.9 t square plus 19.6 t plus 1. If you try to find out the vertex of this one, vertex is the x coordinate of the vertex can be found by using this formula negative b over 2a. In this case, negative b is 19.6. 2 times a is negative 4.9. If you divide this by this, it will be, let me just divide 19.6 by 4.9, divide that by again 2, so that will be 2. And then the y coordinate is the value of the height at 2 when time is 2. That is, actually you just plug t equal to here, which is negative 4.9 times, so this should be t, okay, and this is the value of the y coordinate of that function, which is negative 4.9 2 square plus 19.6 times 2 plus 1. So let's solve this one. So this is what is that, 2 square times which is 4 times 4 times 4.9 is negative 19.6, plus here it's a 2 times negative 19.6. So if you subtract one of the negative 19.6, it's eventually negative positive 19.6 plus 1, which is 20.6. That's the height. So we know the vertex of this height function. The vertex is at t equal to, and then height is 20.6 meter. So to answer this question, we can say, okay, it takes 2 seconds, and then the height is 20.6 meter. So to answer this question, we just have to find out the vertex. Okay. Finally, this is also a word problem, and to answer about maximum or minimum, you need to form a quadratic function. So here, this is the relation between price and demand. So one thing, this is 0.20x, okay. The price P and the quantity X sold of a small flat screen television set obeys the demand equation, this equation. To answer the first question, how much should be charged for the television set if there are 60 television sets? So what is the price? What is the P when X is 16? That's what you need to answer. So you see that P is negative 0.2x plus 220. And to answer the I don't know how to remove that. Okay, it's gone. To answer part A, the price is negative 0.2 times, what is x? X is 60 plus 220. So just use your calculator and multiply that, which is 60 times so what is that, 0.2 times 60 is 12, negative 12 plus 220, that is 208. The price should be 208. To answer the part B, which is what quantity will maximize the revenue. To answer the point, part B, the revenue is actually, it's the price times the quantity we sell, which is P times X. So if you put the value of P, which is negative 0.2x plus 220 times X, which is negative 0.2x squared plus 220x. This is quadratic function. So to find out the maximum revenue, you need to find out the, what is that called? The vertex of this revenue, which can be found by finding the point x equal negative b over 2a, which is b is 220 and a is a negative 0.2, which is basically 220 divided by 0.4. So if I divide 220 by 0.4, that would be 220 divided by 0.4, it's 550. So you are going to get the maximum revenue if we sell 550 items. And what is the maximum revenue? That's the value of the revenue when x is 550. So we have to put x equal 550 here, which is negative 0.2 times 550 whole square plus what is that, 220 times 550, 220 times 550. So if you use your calculator here, you can find out this value. I'm going to use my calculator. So 550 whole square, 550 whole square times negative 0.2, so which is negative 60,500 plus 0.2 times 550 whole square, which is negative, plus 220 times 550, so which is 60,500. So the revenue would be 60,500. So this is the maximum revenue, 60,500. And then this maximum revenue can be we can have maximum revenue by selling 550 items. Okay, so let's go back and then answer this. Look at the answer. The first answer is 208. If you want to sell 60 sets of television sets, then price should be 208. The quantity will maximize is 550 and maximum value is 60,500. Okay, and then what price should be charged for the maximum revenue? So since we know that maximum revenue can be we can get the maximum revenue by selling 550 items, so the price, for the price we are going to use this price and demand equation, which is negative 0.2 times x plus 220. Just plug x equal to 550. So and then use the calculator here. That will be let me just use my calculator. It's a negative 0.2 times 550 plus 220, which is 110. So the price of that television set to have maximum profit should be 110. Let's check the answer. Absolutely correct. So those are 30 questions from practice test 3, but in the real test there will be 20 questions only. Try this assignment as many times as you need or want. Okay, all the best.